Our next talk is from Cheuk Ting Ho, and the title is Epic Evolution of Typing in Python. How we get here and where are we going?
Hey, hello. Can you hear me? Can you hear me? Oh.
Let's put that on now.
Oh, okay. Okay. I hope you can hear me and come in. Don't worry. We just started. You didn't miss anything. So, yeah, let's talk about typing. I know some of you are already very familiar with it, but it's just kind of like a retrospective of like how it got started and where are we going potentially. So, first of all, hello, I'm Cheuk, and yeah, why am I talking about this? Because I have loved Python since 2017. So if you remember 2017, I think the version was, do you remember what version was 2017? Python? Yes, no? 3.6? Yes, but at that time, my colleague told me to use 2.7. That's what happened. That's what happened. But yeah, but like it was like Python 3.6. So it's still very early stage for typing in Python. And I will give you a timeline of like, you know, which version of Python we have what typing feature later. Also, I wear different hats. You know, when I work for my company, JetBrains, I wear the hat of developer advocate. So if you have any PyCharm issues, you want to complain or you have a wish list, come to talk to me. And I'm also a PSF director and fellow. So if you have any questions about, you know, Plone Foundation and, you know, how we do things and, you know, any opinion, like come talk to me. And I have cool stickers. So if you want PyCharm stickers, talk to me. And also if you want my sticker, I have my own sticker, come talk to me. So, okay, let's get started. So, do anybody know the answer of this question? What's the typing system of Python? Duck typing, okay, that's one answer. Anybody have another one? Is duck typing a typing system? Okay. Sorry? Doesn't have one. Okay, so I know everybody have their own opinion and own version of answer to that. So my answer, I think, is the most accurate description is Python is a dynamically typed language, but with an asterisk there. So like, what is this? Okay, let's look into it because, you know, everybody have their own answer of what is the typing system of Python. So let's look into what is the actual typing system of Python. So first of all, as you know, there are different typing systems in programming language. So it's quite important because, you know, all the programming language talk about this is, you know, part of the language design itself. And why do we need it? Because like it's a set of rules how you can label like different data types. And it's useful because you want to formalize it. You, like for example, if you have some interface between different parts of the program, you want to be able to specify like this supposed to be what kind of data, right? So it's, you know, some programming languages kind of, you know, have these so that it's actually easier for debugging. So for some language, if you compiled it, there will be some checking of the type so you know if you made a mistake. There are, again, like a lot of different ways to type in a language. I would personally, and also like generally, like, you know, the developers will agree that there are like majorly two different types of typing, like strong or weak typing. So in Python, we just talk about that it's a dynamically, in asterisk, that it's dynamically typed language. It's good for, you know, there are lots of reasons why when Mr. Guido von Rossum, when he started, he, you know, designed Python this way. And it keeps that way for quite a while. It's because if it's dynamically typed, if there's no enforcement in the runtime for the type, it's easier for people to learn. I remember when I was, you know, a teenager, when I was learning a programming language, you know, I was learning not Python. I always need to declare like what variable that is. And it's like for me, well, I'm very, you know, I was very obedient. So if my teacher tells me to do it, I'll just do it. But for a lot of my classmates, they would question, like, why do we have to do it? This is super weird. Like, I don't know yet. I'm not using the variable yet. Why do I have to declare it at the get-go, right? So for young people, like my teenage self, when you learn a programming language for the first time, when you are still developing your logical skills and all this, and sometimes like, there's too much detail that a kid needs to learn to be able to understand the usefulness of typing. So if we can, bypass it, it's maybe easier to motivate a kid to learn how to program rather than like giving a lot of, details for them to digest. Also, if we are just writing a script to just quickly get something done, maybe we don't want to worry too much about the typing because the program is small, it's not that hard to debug. We don't have all this problem of like, a huge, monster of code that like, oh, you want everything to match and stuff like that. So yeah, maybe it's better, it saves time, and especially in runtime, if you can skip ahead and don't have to, verify whether the type is correct all the time, so it's faster. And also, like someone mentioned duck typing, so like the idea of duck typing is that if we quack like a duck, if we like walk like a duck, it's a duck. So this is the idea of like we just test whether the variable behave like what we expect it to be, rather than we have to label it as a type and check the type. So it's more practical. It's like if it works, then it works. It's not like does it match the label? So we guess if it works. Also, it's a more flexible API. You don't have, again, like you don't have to put too much, rules in it. So, for something that, doesn't need too much rule, like prototyping or small code, it's better. However, I emphasize a lot on the small code part of things, because if you have a huge program, it may be an issue if you don't type everything, because you may realize that there's like some mismatch or something that doesn't work together in your huge, giant code base. So it's more prone to error. And also, the worst part is you didn't know until the program is hitting that part and it's actually some problem arise. It will only get cached in runtime if you don't, now we have type checker and all these amazing things, but if you don't have it, like, let's say you use vanilla Python, nothing else, yeah, that's what's going to happen. And it's very hard to maintain. There's a lot of error could happen. Hard to debug as well. If something just blow up, it's just blow up. You don't know, actually, there may be a type mismatch, and then you put something wrong, and that's why. Also, it's not just for yourself, right? Sometimes, like, your code, you'll be a library. They are meant to be used by other developers. So sometimes typing is actually work as a documentation. It's like explaining what for example, your function is expecting. If you don't have it, if you don't type it in your code, then you have to really be specific in your documentation. And I know that there's lots of like documentation, like generation tools that can actually, generate the documentation from the typed code. So if you don't type it, this information won't be there. So, yeah. So now Python is growing. And Python is not, if you have, anybody have watched the Python documentary that was released this year? Yes, we all know that like Python has been changed a lot since the first day, especially from 2 to 3, right? Like in the documentary, talk about like, so many things change in 2 to 3, and it's so hard for the community to move on. And yeah, but not everything is like from 2 to 3. Like some of the things that the community just adopted because there is generally a need for it, and the community is pushing for it. So typing is kind of one of the things that has been adopted throughout the year. Because Python is not like the first day that was like meant to be a scripting language. It meant to just be quick and fast and to just do some task automatically. Python become a tool that a lot of companies are depending on to build the application. In the documentary, you see that actually some big company, Instagram, is using Python. So these companies and these teams are actually craving for a better way to work in Python as a team, professionally, and have big code base. So Python have to step up and evolve. So we go from this, which is like, dynamic, everything, you don't have to worry about the typing, yay, to this, that now we have a typing standard library. You can, import things in it. There's a lot of tools you can use. And then now you can have annotation in your function to kind of specify what type it is. Actually it adds a lot of different syntax to the Python that was before. So when was it before? So this is the timeline that it's very rough. I just put it together. I think it's for a half an hour talk. We can't have all the information. It would be maybe it would take more than an hour to explain everything. But this is the very simplified version of how Python was evolved from. Actually, it's from 3.5. So that was, around the time when I started Python, right? So I remember I started 3.6 just come out. So, lots of people still using 3.5 or 2.7. So it's from that time people are starting to put effort and putting attention to typing. So until very recently, now the current version 3.14 just came out earlier last week. And but a few versions before 3.12, there's still new typing mechanism that has been added to Python. So let's look at it. So this free PEP, I would say that is the three of the most important PEP in kind of typing. So 3.5 introduced this PEP for H4. That is when typing become a standard library is added, so typing become a thing. But before that, actually, there's already some PEP trying to add some annotation to functions. So even before 3.5, before PEP for H4, there is already people already, the community start thinking about I think it's the FS lead by Mark Shannon. He already started thinking we need to annotate functions and stuff. So that is pre 3.5, so pre-typing. And then finally we have typing. So we have type hinting. We have the typing module. So that's after 3.5. And then, so that's good and all, but I think the community really want more things, and there are some limitations in the typing module. So in 3.9, so that's PEP 5H5. So the standard, typing is actually in the standard collection. So it's not a module that you have to import anymore. It's already, in the built-in. So we'll look into that PEP in a bit as well. So that's making typing more of a standard thing in Python. So after that, we have the most recent PEP 6.9.5, which is Python 3.12, adopted in Python 3.12. That's the type statement. Who have used the type statement here? Yay! So yes, we do love typing, and it's really helpful when when you need it, then you can actually have a more rigorous typing with the type statement. So it all started, before it's already something, but officially it started PEP 4H4. So this is a joint author by Guido van Rossum, Julka, I think I pronounced it correctly, Lektos Sado, and Lukas Lanka. So, big names, core devs, they have created this PEP to introduce optional type hinting. So the most important thing for this PEP here is that it's optional. So it's introduced typing, but a lot of things are optional because it's the first time the Python is officially adopting typing. So you need to really care about the backward compatibility. So if there are users who don't want to use typing and don't want to add these, they should still be able to run their code, right? It should be more smooth and not having the bump like Python 2 to 3. So is at runtime, nothing have really changed. It's just that this type hinting has been added and has been standardized. So hope the community is going to work from there to add the typing need. So, and then Lukasz improved the previous PEP. Now there's like PEP 5x5. So again, so before, if you want to use type hinting, you have to import typing. But now, actually it's built in. So you don't necessarily need to import it. And also it adds this collection, the generics, which you can use. So it actually, again, it's moved from the typing aliases into built-ins. So it really gives typing its place in the Python language itself. So it just, and I think at this point, the community is more and more used to typing, and then I will talk about the tools that come with it as well later. But this is just making sure that typing is a very easy to use feature in Python if there are needs for it. But at this stage, you can still ignore typing if you really have to. But I think now at this stage, most serious Python programmer is already doing typing. So the latest one by Eric Trout. So this PEP is is authored by him, but is sponsored by Guido because he is not a core developer. So all the PEP that is not authored by a core developer need to be sponsored by a core developer. So this is sponsored by Guido himself. So he supported this PEP. So now since there's type statement there, you can actually declare a type just like a static language that we're used to, like C, Rust. They all you have to declare the type of a variable, and now with the type statement you can do that. So it makes the typing more clear in your code, and also it makes the generics more expressive. So before type hinting, it's just always you just put it as a what input it should be and what it should be returned, and now you can declare specifically which variable in what scope in their scope, what type it should be. So it makes things more vigorous and easy to use for people in the community who really want typing. So okay, those are all good and all, right? The community wants typing in Python. It has been introduced via various PEPs. But at the end of the day, Python is still not enforcing typing by default in the runtime. So how can we achieve typing in Python, right? Yeah, we can all use those syntaxes, but if nobody's checking it, the runtime, because runtime is still neutral, it will ignore it, it will still run. So what's the difference? Well, because now we have typing tools. So type checkers. Name your favorite type checkers, please. One by one, please. Okay? MyPy, yeah? Yeah? Pi, right? Pi? TY. TY, yes. Black is technically not a type checker. Okay. Pi, right? Yes. Okay. Good. You all love type checkers. I love people who love type checkers. So actually, type checkers, there's two types. There are static type checkers, which the difference between them is that static type checkers, basically, they don't run your code. They just read your code and then check it that way. So, so you already can think of oh yeah, the type checker that I use actually is static type. But there's also another type, which is dynamic variation. which become more and more popular right now, because if you have an external application, you may have to sometimes do some validation during runtime. And for those cases, static type checker is not good enough for you to use. So those type checkers, we already heard some names now, like MyPy, TY, and Pyrite is also a static type checker. But I think the more popular one these days is the Pyrify. That one is also written in Rust. That's why it's popular. Okay, so the dynamic variation is, of course, Pydantic. I think now is a big name. A lot of people know about them. And Marshmallow, least well known, but it's very similar with Pydantic. That one is written in Python. So, yeah. Why this is, some of them are really popping up, they're new, they're catching a lot of attention, like TY, Pyrify, and Pydantic, because they are written in Rust. So why? Well, because if the tool is written in Rust, a lot of them, once they are rewritten in Rust, they improve the speed a lot, which is important for type checker because you don't want them to get in the way of your normal workflow, right? Like for static type check, you don't want them to get your CI to be super slow. In dynamic variation, especially, you don't want application to slow down because of the checking. So static type checker, one of the example is MyPy. MyPy is there from the first day because it's a reference implementation of PEPS 4H4. So once 4H4 come out, people know that, right? Because now we have all those nice syntax, we need to check it. So MyPy come out and it's use the type tin and catch the a potential error. It gives a lot of support, so you can use it in a lot of inner junction to a lot of other frameworks. Also, you can configure it yourself. You can have configuration files. So the community loves it. It's good. But it's written in Python. So the other example, which is totally different, is the dynamic type checker. Pydantic is just dynamically verified the type of your of your data, your data structure. So what it does is that it will serialize it into a JSON format, and then you can, in your code, you can perform some validation and do some checking. And Pydantic, actually, right now, people talk about Pydantic. They're actually talking about V2, which is actually built on Rust. So so it's way faster than the previous version, I guess. So so it's pretty awesome. Okay, I have a little bit of time, which I would also edge into the Q&A session as well. So this is a short survey, only 3 questions for you. If you can quickly fill it in, it will be very useful because I want to know what the community think about typing in Python, which is, useful for the community and also useful for our team of developers to develop the tool as well, because they know what you want, they will develop what you want. Yeah, I'll give you some time, and yeah. Cool stuff. Yeah, so that's so the survey is actually the end of the talk, and you can, if you want to take some time to answer the questions, it's also fine. But yeah, so that's my social media. It's in that QR code, and thank you so much. I think we have a little bit of time for Q&A, right? A little bit. Okay, thank you.
And do we have some questions? Here's the first one.
Hello, thanks for your talk, first of all. I've got a question about, you were mainly talking about, things that are already existing. What about, future? Do you see, some, how it can evolve, or, how it evolves already? Yeah,
so my personal opinion, of course, the core devs may have other opinion, but my personal opinion is that since now we are moving to a 3-threaded Python, typing maybe become more important for those people who are like advanced Python users who want to do super complex concurrent applications. Then static typing become very important because once the program get more complicated, you want to have a clear view of what's going on. So with typing and type checker will help to catch those typing issues or potential bugs way earlier than, because if you have debugged a concurrent Python program, you know it's very hard to debug a concurrent program. So I would just think that typing become a more and more useful tool in the future. Any more questions?
More questions? Anyone?
Yes.
Hi. What's your stance on PEP 718 about subscriptable functions for typing?
Cool.
So, for the subscriptable function for typing, I haven't dived into the detail of that PEP yet, so I can't give you a very concrete question, but we can maybe do the discussion afterwards. Yeah. Yes.
Okay, I have a question, especially because I'm going to give a talk in 7 days about exactly how we're going to answer that. Imagine, hypothetically, you have a project with a Python code base dating back to 1996. And hypothetically, okay? And imagine that this code base implemented a bunch of stuff that Python developers are discovering these days. For instance, the whole idea of protocol is so amazing, and this code base has something like that since 2000? Yeah, and just imagine that. But nowadays, it doesn't matter because the whole Python world went in a different direction, and we're talking about 200 different packages. So it's not like something you can do on a weekend. How do you suggest that such project with 30 years of code, with many different packages, and with a community that's getting old fast, could start implementing typing in a sane way?
Oh, I feel like it's a field of mine that you laid down. Of course, hot take. Don't get angry with me, but it's just my opinion, okay? I think that that's why in the typing there is a lot of it's still very backward compatible. You don't necessarily need typing to run your code still. Even if, I think for a very old program, if it's open source, then, if it's not maintained and, the community find that maybe it's not that relevant anymore, then maybe there will be a replacement for it that has to do the same job, but, that you can replace it with something that is more modern and can do the same thing. It may be painful to migrate, but at some point in time you have to bite the bullet and do that because you want the maintainability. And if it's something that's nobody knows anymore, it is super hard to maintain. I think we have a lot of computer program made that mistake before. I've heard that there are some programming language, they have to get someone in hospital, is in care homes or whatever, to wheel that retired old developer back to maintain a program that has been not touched for years. We don't want that. We want to prevent that from the get-go. So I think Python community is still very young, still have new people coming in. That's why investing in the young people and teaching them and hope to, not let the dust get too thick before you, thing.
No, you don't.
Come on.
No, you don't.
Can we do it outside?
Okay.
Because they will kick us.
This community has a piece of code wrote by a Dutch guy. Should we bring him back and force him to type everything? let's say this person name starts with Hido. Ends with Van Hossen. Do you think he's willing to come back and fix that?
Well, that's why he passed it on to a team of young and very capable people to handle it for him.
Unfortunately, we have to quit now. Thank you.
Thank you.